Hi, everybody. We are beginning our study of surveying, and this is our introductory lecture for both engineering surveying and practical surveying. So for those of you in engineering surveying, ES 2070, this will take the place of the lecture scheduled for 2 p.m. on January 16th. And for those of you in practical surveying, this will take the place of the lecture scheduled for 3 p.m. on January 18th. If you are in engineering surveying, you'll want to follow along in this book. And if you are in practical surveying, you will want to follow along in this book. At the end of this recording, I'll assign some homework taken directly from the book. And so you'll be able to follow through the surveying homework based on which class you're in. But the material is pretty much identical. So the first chapter, which serves as an introduction, defines surveying and talks a little bit about the history of surveying, and then also talks about why we survey. So surveying has been around pretty much as long as human beings have been around. The idea of surveying basically comes from the idea of defining the boundaries of your land and building stuff to put on your land. So if you're building a home, for example, before you start, you want to know where the corners are going to be. You want to make sure that everything is square and true. You want to make sure that the size of your home is compatible with your budget and so forth. Also, an example in modern times is the idea of, if you look at roof lines, most modern houses have very complicated roof lines, and everything needs to meet up and the water all needs to run off of the roof. So making sure that you have a roof that will facilitate that is definitely a requirement of a job. Now that type of surveying is referred to as construction surveying. The other type of surveying, which is called land surveying, is concerned primarily with boundaries, so that you know where the boundary is between your land and your neighbor's land, for example. The thing about having knowing where to put your fences is a way of defining the relationship between your land and your neighbor's land, and knowing where you can build things and what land you're entitled to. Because ultimately, land ownership is about rights, the rights associated with owning that land. And so if you are, if you know where your land boundaries begin and end, you know where you have entitlements to act in certain ways and to use your land in certain ways. And similarly for your neighbor. So that kind of goes back to the expression, good fences make good neighbors. We often think about surveying as requiring expensive or modern equipment, but surveys have been done in a lot of different ways before we really had access to good equipment. Right now, a lot of surveys are done using GPS or lasers, light rip waves of some sort. We will use different types of equipment. In our first lab on the 16th of January, we're going to use a very old school type of an instrument called a steel tape. But a steel tape can give you distances in a pretty precise way. Later on, we'll use more sophisticated equipment, optical equipment, and laser equipment, and we will have a demonstration of global positioning system, which is really the next generation of surveying in terms of accuracy and especially in terms of data collection. So the picture on the screen right now, figure 1.1, shows some different old-fashioned surveying instruments. The item in B right here is called a plumb, or a PLUMB, and what a plumb does is it basically points straight toward the center of the earth. The instrument on figure A is referred to as a diopter, and it just measures angles and makes things horizontal, or measures where a horizontal will be. So if you can find vertical and horizontal and an angle in a plane, you're really going to be able to do a lot of different kinds of work. You're going to be able to determine if water is going to run downhill or where it's going to run. Um, and water running downhill is a big deal if you think about it in terms of our modern living, bringing water into your house and taking waste out of your house, and also having stormwater move away from your house. Those are all practical applications of water running downhill. So the word plumb or plumb bob, as an example in beam, that the whole instrument there's called a gromma, but the little weight on the line that points straight down is referred to as a plumb. Plumb is from the same root word as plumbing, because one of the main early uses of plumb, of finding a plumb square and true, was to make sure that water ran into your house and ran out of your house. And so if you ever look at the symbol for lead, the symbol is PB, which stands for Plumndan, and that is basically because plumbing was made out of lead in ancient times. We learned since that that's a terrible idea because lead also contributes to heavy metal poisoning, but at the time it was not known that that was a problem. So these sort of survey instruments were used in order to find points and to determine if water runs downhill, also to determine boundaries of your property and other types of construction. So if anybody was ever told that Columbus discovered that the world was round, first of all, Columbus did not discover anything about the shape of the world, and second, the world is not round. The shape of our planet is actually a spheroid, which means it's nearly a sphere. But if you look at a basketball or a globe, you'll see that it's nearly a perfect sphere, meaning that if you start at the very center of the shape and you move outward, that the distance to the surface would be the same in all directions. The Earth itself is not actually spherical, but it's referred to as an oblate spheroid. Oblate just means flattened. Spheroid means kind of like a sphere. So if you look at the Earth, it's actually more pear-shaped in the sense that the southern hemisphere is a little bit thicker than the top hemisphere, and the north and south poles are slightly flattened. But we approximate the shape of the Earth for purposes of measurement as kind of a net that looks like a sphere, and then we correct that net to the actual surface of the Earth. The figure here in 1.2 goes back to the idea that I just said, that Columbus didn't discover anything about the shape of the Earth, but basically there were two towns in ancient Africa during the time of the Egyptian Empire, and there was a person who checked to see, his name was Eratosthenes, and he wanted to determine the circumference of the Earth. Now, circumference means the distance around, right? So the very fact that he understood there was a circumference of the Earth indicates that Eratosthenes knew that the Earth was not flat, because the concept of circumference is nonsensical when it comes to a flat surface. So what he did was he realized that the sun, these are both very near the equator, the sun would be directly overhead at Alexandria at a certain time of the year, and would be directly overhead at this other town, Syene, at another time of the year. And what he did was he actually waited to determine, how do you know if the sun is directly overhead? Well, his scheme was to look down a well, and when the bricks on the well did not cast a shadow, or the rocks on the well did not cast a shadow, meant that the sun was going directly through the well from the top to the bottom. So he did this at Alexandria and Syene, and he knew the distance of the arc length, or the walking distance between the two, and based on this distance, which would be the arc length, and the angle subtended, he used a trigonometric calculation to calculate the circumference of the Earth. And it turns out that it was quite accurate, and actually was within just a few percentage of the actual circumference of the Earth. So this is one type of surveying that used basically no material whatsoever, no equipment, and was basically done more or less as a thought experiment and understanding something about the nature of the universe. This is a picture of a surveyor using an instrument called a total station, and we actually have two of these in our lab that we will be using later in the year. They use light waves, so sometimes it's called laser, but it's not actually a laser, but it's different wavelengths of light that we use to reflect back from a prism, and then by doing some calculations, some data reduction of the waves, we can determine how far the prism is from the total station and thereby determine the linear distance between those 2 points. This is a picture of a person using a global positioning system. Generally speaking, a global positioning system will use some sort of a stationary setup and a roving setup, and the setup can be in a person's backpack. This is a little less modern than the one that you'll get to see, or you can just use a stick with the rover on it, and it can accurately measure the distance between 2 points, and it can also store a huge number of points so that you can go back and refer to points that you measured in the past and find them based on other known points or points that you establish at a different time. And that's just a picture of surveying on modern freeways. So freeways are a really interesting problem because, as you can see here, we sort of have a cloverleaf issue, but roadways are not built in their entirety for the most part. They're usually built section by section, and old sections are attached or connected to the newer sections. And in order to do that, it really becomes a three-dimensional problem. So in addition to everything having to meet up in all three directions, up and 2 directions over, you also have to keep grades on the roadbed that are federally mandated. For example, if you're on an interstate highway, you have to have certain stretches that are flat and straight, because one of the main purposes of the development of the interstate highway system was the potential for landing aircraft in times of war. So interstate highways have very, very certain parameters that you have to construct them under. And this is just this is not really going into that aspect of the interstate highway, but basically the complexity of it, where you have 5 roadbeds that all have to connect to different roadbeds, and they are all going in different directions. So everything has to be pretty perfect, and modern surveying equipment can facilitate that. So one of the most important parts of surveying after we collect all the data is going back home and using our computers in order to reduce the data and to create something other than just lists after lists of data. And one way that we store data is in a GIS system, which is called short for Geographic Information System. We can also do plots where we have diagrams that we produce, or land plats. And a land plat is actually part of a formal document that can define land or transfer land from one person to the other. So if we take a look, for example, I'm going to move the webcam down and show you a plat of the soccer fields here at Northwest College. In just a second. I'm going to turn this on for you. Okay. And, oh, I have to turn it the other way. Sorry. Got upside down. All right, so there we go. So this is actually a plat of the Northwest College Foundation land, the Krebs Edition. This is 8th Street and 7th Street, just north of the building that we're in, the Math and Science building. And over a little bit, so here's Division Street. So if you think about it, our building is somewhere over here. The Krebs Edition is actually where the soccer field was put in. So this document describes very precisely where that land is and allows for a transfer of land in this case from the Northwest College Foundation to Northwest College, so that we could put in the soccer fields. All right, so as we continue talking about surveying, there are different types of surveys that we use, and there are specialized types of surveys, such as we've talked about two basic types: land surveys, which are also called boundary surveys, and construction surveys. But there are a lot of other types of surveys that are listed in your textbook that are done for different reasons. For the engineering surveyors, this is on page 11, and I'll talk a little bit about some of these surveys, even though they're not specifically dealt with in the practical surveyor's textbook. It's kind of an important idea. Control surveys, for example, are used to establish horizontal and vertical monuments that serve as reference frames for other types of surveys. One way to think about this is, if you are working on a construction project, if you're surveying in a road, for example, you can't really stake the center line of the road very effectively, because all of the equipment is going to be passing over that, and you're going to be knocking out survey monuments. Now, the problem is a little bit more complicated than that, and we'll talk about other areas or other reasons that we use control surveys. What a control survey would do in that case is we would put points at very well established locations off to the side, and then we would survey our center line or our construction from those points that are off to the side. A topographic survey is one that determines locations of natural and artificial features. Any of you who've ever been hunting, if you've used Forest Service or a USGS map, those tend to be topographic. They give an indication of the elevations and what landmarks you're expecting, so that you can sort of orient yourself on a map based on not just on north, south, east, and west, which are the cardinal directions, but also on features that you'll see as you were going through the land itself. So other types of surveys you can take a look at if in the engineering surveying book, and just read some of the. And they also sort of are tied into the idea of the reasons for surveying. Now, in our class, one of you students asked if we were going to wear yellow vests, and as I said, not generally. If we were in a situation that we had to survey something in where we had traffic issues, or if we were in an area that was just heavily populated, we would wear yellow vests. It's also important to wear safety glasses if the environment requires it, closed-toed shoes, and of course hard hats. So all of the data that we collect from surveying, you can do it either for personal reasons. For example, if you had a sprinkler system at your house and you knew that at some point you're going to have to dig it up and work on it, you may want to do a survey and do a plat of where all of the equipment is, so that you're not going to have to dig up your entire yard to find where your sprinkler heads or your pipes are. Other types of surveys are recorded for other reasons. For example, here in the United States, Wyoming is a public land survey state, and the data here was actually collected in relationship to a set of control surveys that we'll talk about later on, that define our piece of land, wherever we are, for example, the township of Powell, in relationship to all of the other land in the public land survey system. And all of that data is recorded. Here in Wyoming, it's mostly recorded at the county courthouses. So that's important stuff, so that we don't have to reinvent the wheel, and there's a lot of legal implications for that as well, that we will talk about as we go on. One of the things that I would like to bring to your attention as we talk about the public land survey system is the Western United States was developed according to this system because huge tracts of land were purchased, and quite frankly, we didn't really know what we were getting ourselves into. So if you look at the ancient, not ancient, but if you look back to the Revolutionary War, a lot of our founding fathers were, one of their professions was listed as land surveying. And there was a lot of reason for that, but there was a lot of surveying going on. And a lot of times also after the Revolutionary War, a lot of the soldiers were paid in land because the United States was very cash poor after we separated from England, but we had a lot of land, I mean, relatively speaking. And so being paid in land meant if you could survey your own land and declare it your land, and to have a legal stake in that, that you might have a chance of getting better land than if you had to rely on somebody else to do that for you. So one of the biggest purchases that affects us here in Wyoming would be the Louisiana Purchase. And in the early 1800s, land was, the continent of North America was owned by different governmental entities. The colonies were owned by England, and that's sort of what took over the rest of the continent. But there were also pieces of land, big tracts of land that were owned by Mexico and Spain, and of course France. And so we got a lot of land from, for example, the Louisiana Purchase, which was purchased from France, and then we had to do something with it. And at that time, the United States really, the government really wanted us to expand into that uncharted land. And in order to do that, we gave land not only to individuals, but also to school districts and townships and railroads later on. Railroads really made European expansion into the western United States a viable and going thing. And so railroads were given a whole bunch of land in order to encourage that expansion into the American West. So all of this that we're talking about is discussed in your textbook. So practical surveyors, you will read a little bit more at this point about the westward expansion and the Louisiana Purchase and the building of the railroads. But also it's important to note that all of these things were systems put in place by the United States government with an eye toward expanding population into the West. And the main reason for that was the development of resources, whether the resources were farming or mining or farming, ranching, and mining were really the sort of three big things that happened out here. And later on, the idea of bringing water to the West, because compared to other parts of this continent and other parts of the world, the American West has very, very little water. It's very dry, and it's very hard to raise crops out here without the support of irrigation. So irrigation was another big push for big surveys. So as I close this discussion today, what I'd really like you to take away from this is that surveying is involved in a lot of different aspects of our lives. It's involved not only in the personal ideas of constructing your home, finding where your yard is, defining where your sprinkler system is, but it's also in these big ideas of public works, railroads, governmental decisions. So all of these things involve taking accurate measurements and then also describing those measurements both in words and in pictures. So that's where we're getting at with the idea of surveying. So for practical surveyors, at the end of chapter 1 in your textbook, there are 31 review questions on pages 23 and 24. I would like you to complete those 31 questions for me, and that will be due in 2 weeks. So the homework, chapter 1 of the practical surveying textbook, will be due on Tuesday. Let me think about what day that would be, the 23rd, the 30th, January 30th. And for the engineering surveyors, in your textbook, there are 21 questions at the end of chapter 1 on page 19. So that will be your homework. That will be due at the same time. So in the meantime, this gets us out of one of our lectures, and we will meet tomorrow, which is January 16th at, normally we would meet at 3 o'clock. Tomorrow I have a meeting at 3, so we'll meet at 3:30. I will send you an email to that effect. We'll meet at 3:30 to do our first survey. Please dress for the weather, and please bring a field book, which we talked about last time. So thanks, and we'll see you at 3:30 on the 16th.